Note 6a. Domain and range of quadratic functions. Objective. I can write the domain and range of quadratic functions using inequalities. Essential question. How do I use inequality notation to define the domain and range of a function? While you do these notes, I expect you to join the Pear Deck and contribute to the slides, watch this video, fill out your foldable, and ask questions whenever needed. Here's the vocabulary for this section that you need to become familiar with. Know how to pronounce these words and what they mean. Domain, left, right, x. All input values x, which will produce a valid output from a function. Range, down, up, y. All possible output values y of a function, f of x. Inequality notation, used to show what two values the domain or range is in between. Unbounded, open, less than sign. In between but not including endpoints. Bounded, closed, less than equal to. In between, including endpoints. Maximum, the highest y value. Minimum, the lowest y value. These two things together are called extrema. Here's some examples of using domain and range to determine if a relation is a function. Domain, the list of x values being used, no repeating. So for this set right here, the domain is 2, 5, 9, and -2, and then you would write those in order from least to greatest. In this table, the domain values are the 3, 6, 8, and 10. It's the x values. For this mapping diagram, the domain would be the input values. They are the ones without the arrow. It's the side without the arrow. And then this one is a discrete graph. The domain is each of the x values of these coordinate points. The range is the y values being used with no repeating. So if you had a number that repeated twice like this -12 here, you'd only have to write it once. You'll have to repeat domain and range items in a list. For the table, it's the y values. For the mapping, it's the side with the arrows. And then for the discrete graph, it is the y coordinates of these points. Now this one is not a function because this part right here, we have two x's, two y's mapping to the same x. So it's like one kind of x has multiple y's. You can't have that for it to be a function. Set builder notation. Set, a collection of objects indicated in math by braces. It's usually used to count discrete items. Set notation example 1. 1, 5, 32 is a set. Commas separate elements in a set. If you are given a set 1, 2, 5, 3, 32, 7, the domain would be x such that x equals 1, 5, 32, or simply the domain equals braces 1, 5, 32. What would the range be for this example? Drag the numbers in the correct spots. Set notation example 2. If we have equation f of x equals -3x squared plus 1, and the domain is -1, 0, 2, the range can be found by inputting each x value into the domain. So, f of 1 equals -3 parentheses -1 squared plus 1 would be -2. f of 0 would be negative 3 times 0 squared plus 1. 0 plus 1 is 1. F of 2 equals negative 3, parentheses, 2 squared plus 1 equals, have negative 12 plus 1. They give you negative, what? Negative 11. Alright, so therefore the range is, put the smallest number here, put the largest number here. Inequality notation review. So let's review these inequalities. So this symbol means less than. This was less than equal to. This was greater than. This was greater than or equal to. Unbounded symbols. Parentheses tell us that the interval is open. Other open things include infinity symbols, inequality signs without lines, arrows, dashed lines, and holes. For bounded symbols, we have brackets. Brackets tell us that the interval is closed. Other closed things include inequalities with equal signs under them, solid lines, closed points, and vertices, extreme values. Domain of lines review. In this example, the domain is, for figure 1, it's negative 3 is less than or equal to x is less than or equal to 2. Both negative 3 and 2 are included because these are both closed points. Figure 2 is negative 3 is less than or equal to x is less than 2. This one is a hole. And then this was a point. And then figure 3, we have negative 3 is less than x is less than 2. Neither negative 3 nor 2 are included. They're both holes. So since these are both holes, they're not included in the set. So these inequality symbols is basically to know if in between includes the numbers or not. The endpoints. Labeling for finding domain. So remember, domain is left, right, x. On the graph, we're going to draw two vertical lines. One on the left side of the picture graphed, and one on the rightmost side of the picture graphed. The left side, we have 1, 2, 3, 4, 5. This is negative 5, so this one is negative 5, comma, something, which we don't care what that y value is because we're only finding domain. And then this point right here is going to be negative 1, comma, some y value. The y value is 3, but again, the 3 is not important here because that's for the range. The hole on the left side has no line. The point on the right side has a line. And the x goes in the middle. This one right here has arrows on both sides, the left side and the right side. When it goes left forever, x is approaching negative infinity. When it's on the right side, x is approaching positive infinity. So that's negative infinity to positive infinity. You might see this symbol, all real numbers. You might see it spelled out, all real numbers. And the informal way of writing this would be inequality notation. Now, you'll probably never see this, but this is a way you could think of how you would label this. Alright, so you go ahead and do this one. Draw on this slide Draw vertical lines through the leftmost and rightmost x's. Label the points, holes, or arrows that go through these vertical lines. Then state if it's open or closed. So it gives you the solution here. You just need to show the steps on how you got there. It's similar to this example right here. Draw your vertical lines, label your points, and then say if it's a hole, open, or a closed point. Domain, increasing versus decreasing. So increasing has positive slopes. When reading from left to right, the y values are increasing. Decreasing, when reading from left to right, the y values are decreasing. They're going down. We're always going to read from left to right. Domain of this one is all real numbers. The vertex here is a minimum. We have 1, 2, 3, 3, comma, 1, 2, -2. So it's increasing on the right side, where x is greater than 3. It's greater than 3 because it's representing the right side. It would be decreasing where x is less than 3, left side. Labeling for finding range. So for finding range, that's down up y. To find that, you're going to want to label the lowest point and the highest one. You draw two horizontal lines. The lowest one is at y equals 0. The highest one is an arrow, so y is going to be approaching positive infinity. So our interval would be from 0 to infinity. You'd write y is greater than or equal to 0 for your inequality. For this exponential function, our lowest one is its horizontal asymptote. It's at y equals 0. The highest one is right here. It's an arrow again. Y is approaching positive infinity. So y is greater than 0. Asymptotes are not included, just like holes are not included, or arrows. Now you try this one. Here is your range. Use the steps to show how you get that. Draw your two horizontal lines. Label each of those endpoints. We have 0, 0, and then positive infinity there. Go ahead and label your endpoints on this one. What's this? What's this? Label those. Range. So we want to find the vertex. That's this point right here. We have -1, 1, 2, 3, 4, 5. We only care about the y value in this one. Your range is down up y, so we're going to draw a horizontal line at the bottom. Looks like y is approaching negative infinity right there. And the highest was right here, y equals 5, your maximum value. So your range is going to be from negative infinity to 5. And 5 will be included. Now to write this in inequality notation, you write y is less than or equal to 5, your maximum value. So it can't go over the max, but it could go under it. And when you're working this out, you could think of negative infinity is less than y, less than or equal to 5. And then you would just take off this part since it's not the formal way of writing it. Inequality versus interval notation. So again, in Algebra 1, you'll mostly see inequality notations. In Algebra 2, you'll mainly see interval notations. They mean the same thing, they're just written differently. So like for example, we have x is less than or equal to 1 or x is greater than or equal to 5. The number line, you'll have the two left and right sides shaded and the middle part not shaded. And then as an interval, you have two intervals just like you had two inequalities. The U stands for union. It's just their way of writing or in that notation. And then if you have another compound equality with and, the x will just go in the middle, and you have your two endpoints on each side. And you'll have one interval, just like you have one inequality. On the number line, it's shaded in the middle, not the ends, the left and the right sides. Remember, all real numbers could be written like this, this, or this. Remember, X domain is read left to right, left, right, X. Y, the range is read down to up, down, up, Y. The arrows are for negative infinity or positive infinity. Negative infinity is going left or down or some combination of that. And then positive infinity is going right, up, or some combination of that. Parentheses tells us that the interval is open. Here's your other open symbols. We have inequalities without lines under them, arrows, dashed lines, and holes. And brackets tell us that the interval is closed. Other closed things is less than or greater than signs with equal to signs underneath, solid lines, closed points, and extreme values, your vertices. Sets have braces and they're used for counting discrete values. What is codomain? All the y values, including the ones that may not be in the range f of x. So we have red, that's the domain. Yellow is the range. And then blue is the codomain. Now, this would only really be used in a situation that has a range already defined. And you're to determine if the domain reaches all of those range values. How do you feel about today's topic? Drag the icon on how you feel about today's topic. Can you explain it to others? You're not sure how to do this yet, somewhere in between? Drag that icon. And now the last slide, go ahead and write your summary. How do I use inequality notation to define the domain and range of a function? Some things that you could write when you would include your summary could be open, hole, closed point, vertex, horizontal line, vertical line.